Hi there, Trish Triumpho Sullivan here again for a little mini lecture on color temperature and filters. So we've talked about light. We've talked about that light is electromagnetic energy, and that it's measured often in they call it frequency, right? So they talk about waves, high frequency, low frequency, and that's just how fast or how frequent the waves are, right? In electromagnetic energy. And so I forgot to talk about a little bit was color temperature. So let's just talk for just a moment about color temperature, because a lot of times we're measuring, the color temperature is measured in degrees Kelvin. And one of the reasons it's good to know about this, about color temperature, is because nowadays we have a lot of lights that are LED lights, and LED lights are measured in color temperature. So the temperature tells you what color it is, okay? And so we had talked about white balance, right? And white balance has to do with the different colors of light that we can be that we can be subjected to, or can affect the quality of our photograph. So like in other words, if you're indoors and you don't change your color balance to say a tungsten or a fluorescent lamp color balance, then or white balance, then you're going to have either a really yellowish photograph or a really bluish greenish photograph. So it's measured in Kelvin. And just to give you an idea, full sun, right, is 5,000 degrees Kelvin, right? And that's like 1.25 million colors, right? So remember, full sun is all the colors in the rainbow. It's every color you can possibly imagine, right? Because color is light. In fact, you guys, this is really fascinating. So you know that color is not a property of matter, right? Color is a property of light. So light, the reason we see colors is because of light, because light has colors. And matter is gray. Like everything is gray. I'm gray. My dress is gray. The ground's gray. The walls are gray. And they're just different shades of gray between white and black, right? And that's matter. That's just gray. It's all gray, because color is not a property of matter. Color is a property of light. So all the color that we see is actually light reflected off of whatever matter it happens to be hitting. So light reflected off my skin is this color, right? Light reflected off this fabric is this color. Light reflected off my glasses is kind of brown, right? Light reflected off of this portion of the marker is purple. Right? Does that make sense to you? So it's important that you know that all color comes from light, not from matter. So everything in our world is gray, and it would stay gray unless we had light coming in. And you can see how that happens, where if you're in a really dark room, notice that you can't see color, right? Things will look different shades of gray. That's because without light, there's no color. So it's important. That's an important little thing to remember about that. So full sun, 5,000 degree Kelvin. A tungsten bulb, remember the tungsten is the old-fashioned light bulb, right, that looks like that, right? So a tungsten bulb is usually about 1,200 degrees Kelvin, okay? A photo flood, right? So if we were using like an external floodlight, right? A photo flood is usually like 32 to 3,400. Let me rewrite that. Degrees Kelvin. So that'd be a photo flood. It's kind of hard to measure, say, fluorescent, but if you're looking at a fluorescent light, it's usually going to measure between, I would say, kind of 25 to 3200 Kelvin. Okay, so 25 to 3200 Kelvin for a fluorescent. And when it's cloudy, right, there's the fluorescent fixture, kind of, if you have it on your camera, it might look like that, right, when you're doing your white balance, right? Kind of like a old-fashioned fluorescent light fixture with the little two pins on each end. Okay, so cloudy days, we tend to get a lot more blue light on a cloudy day. So if it's cloudy, we get a lot more blue light. Remember, we talked about how the blue light, the ultraviolet light bounces around in our atmosphere and makes our sky look blue to us when we look up. When it's cloudy, we get a lot more blue light, and it's important that we know what kind of a filter we might want to use to kind of to get rid of having it look too blue on a cloudy day. So there's different filters. You could use, like, say, for a fluorescent lighting, you could actually put a filter on that would be kind of a magenta filter. Right, that's going to give you some red into the blue, so it'll help balance it off. When you are trying to get rid of too much blue in your thing, you probably want to have a polarizing filter. And one thing you need to know about a polarizing filter, to keep too much blue out of your photograph, because our atmosphere has all this ultraviolet light bouncing around in it. The one thing you need to know about using a polarizing filter is it needs to be used 90 degrees away, opposite the sun. Right, so that's an important thing to know about that, and that would really help you on, say, cloudy days. Or days or times when it seems like there's just too much blue reflection from our big blue umbrella over our heads that's constantly there. So when you're looking at something like tungsten, it's very yellow looking, so you might want to use a cooling cooling filter, because tungsten tends to look kind of yellow or orange. So you might want to use a cooling filter to filter that kind of really yellowish, orangish light that you would get from a tungsten lamp. And then basically, the other kind of filter that you might want to know about, and I think this is, I've used these a few times, it's called a split neutral density filter. And what that basically does is you screw it on the front of your lens, and it has like almost like sunglasses, like up here. Like, you guys have seen those sunglasses where it's tinted up above and then it's clear on the bottom, right? So those kind of sunglasses, it's like the same thing. Those are polarizing sunglasses, and what they do is they help you to filter out the brightest part of the scene, and that happens a lot when you're taking a photograph and you've got some foreground stuff, like, let's say, some rocks and stuff, and then some background stuff. So let's say we have a couple of rocks and some trees, right? and this part's in really bright sun, full sun, right? But this part here is in shade. So if we've got this part, let me get a different marker because it's kind of hard to see. So if this part is in sun, right, this is all bright sun up here, and this part here is in shade, it's going to be hard to get your exposure correct because you've got bright sun up here and then shade down here, but you want to get both of them in, and that's where this split neutral density filter comes in. Is you screw it on the front of your lens, and it'll make this part a little bit shadier, and it'll brighten up the shade part so that you can see the details in the shadow, right? And you can also use that trick with a pair of those sunglasses. Just holding them over the lens can actually help do that. But it only works, okay, when you have part of your photograph is in bright sun, right, and the other part is in dark shade, right? So you can't really see it unless you use the filter. So you'd either have to expose for the shade and make this overexposed too bright, or you expose for the bright part and then the shade is too dark and you can't see the details. And that's where this type of a filter, the split neutral density filter, comes in. So that's about all we're going to cover with filters. The more advanced classes would have more advanced delving into that. But for right now, we're just talking about color, temperature, and filters that you might need for your camera for different lighting situations. So we'll see you in class. Thanks for joining me today.